Okay, guys, so let's actually look at some exam questions, right, regarding calculating your values of Kc, right? So how are they going to test you on your exam and how are you going to answer it? So let's just interpret this statement, right? It actually says that we have got this reversible reaction. Why do we say that it is reversible? Because of these double arrows, right? So these double arrows indicate that products can be converted back into reactants, right? It is reversible. It is a reversible reaction. Now they say we have 8 mole of SO2 and 10 mole of O2, right? So we've got what? 8 mole of SO2 and we also have got 10 mole of O2. So I want you to think as like baking or I don't know, or like maybe cooking something. So let's say we have got, I don't know, we've got some sort of a dish, right? So I'm just gonna like write this dish. So I'm just gonna write it as this. So now, initially, what do we have? Like, this is the stuff that we have before anything. Just like when you want to cook your pap or porridge, you have your maize, right? Initially, you've got your maize. So here, we're being told that we've got 8 mole of SO2 and 10 mole of O2, right? So initially, that's what we have. We're just gonna like write it down. We've got what? We've got the 8 mole of what? Of SO2, and we've also have got the 10 mole of what? Of O2. That is what we have. It is what we have with us. And we've also got this reaction vessel, right? So the reaction vessel, just think of it as your pot or something. That's where the reaction actually takes place. So what do you realize about your reaction vessel before the reaction? You realize that your reaction vessel before the reaction, it is what? It is empty. It has nothing. If something is empty, what do we call it? We call it zero. It is nothing, right? And now, if we look at our diagram, what is our product? If we are focusing on the forward reaction, you realize that your product, it is what? It is SO3. So in other words, right? So in other words, what I want to interpret this like is, I want to interpret it in like this. Initially, this is before the reaction. Initially, this is like initially, we have got this, right? But again, initially, do we have the product? No. You don't start cooking your pap and you have pap, right? You don't have pap. You just have your maize and boiled water. That's what you have initially. In terms of your products, you don't have it. So this again tells us that initially, our product is what? Our product is zero. There's nothing inside the pot, so the product is zero. So this actually means that SO3 initially is zero. So it means that what? We've got what? 0 mole of what? Of SO3 because it is our product. Does it make sense? That's why we have nothing inside the pot, isn't it? So it's not there. So I'm just gonna try to delete this, delete, and also delete, right? So now, what is something that we're gonna read? We say that, 8 mole of SO2 and 10 mole of O2 are actually sealed, right? So they're actually sealed in a what? 500 centimeter cubed. So 500 centimeter cubed means volume, right? So 500 centimeter cubed actually means volume. So I'm just gonna say that the 500 centimeter cubed, this actually means volume. Now, what is volume? So your volume means space, right? So your volume means space. So in other words, the space inside the reaction vessel is actually 500 centimeter cubed. So we have a problem. So each and every single time when we are dealing with chemistry in chemical equilibrium, you don't want to have centimeter cubed, you want to have decimeter cubed, right? So you're just gonna convert your centimeter cubed into decimeter cubed. So you're just gonna divide by 1,000. So 500 divided by 1,000, this is just going to be 1/2 decimeter cubed. So I'm just like converting this to densimeters, right? So it's just going to be 1/2 densimeter cubed, right? So now, what are we eventually going to realize? So this is what we're going to realize. We realize that the 8 mole of SO2 and the 10 mole of O2 are sealed, right? They are sealed in a volume of 500 centimeter cubed. So it means that we're just going to take this in here, and it also means that we're going to take this in here, right? So we've got the 8 mole of what? Of SO2, and we've also got the 10 mole of what? Of O2. And what do we do about it? We actually seal it. We actually seal it, right? It is sealed. That's what they are saying. And what is the space? What is the space of this entire room, of all of this entire container? So the space is actually 1/2 densimeter cubed, right? And remember that initially the space, or rather the reaction vessel, is actually 0. So that's kind of cool to realize. So now we are being told that the compounds react to produce SO3, right? So this actually means that this is our reactants, and they are going to react to produce what? So I'm just going to write this. So this actually means production. So we're just going to have a production, and the production is just going to be what? SO3. Right? And that's what the question says. So the compounds react to produce SO3. But where? This is very important. But where is this SO3 being produced? It is produced where? At equilibrium. Do you see it? So it is actually being produced at equilibrium. So it's very important for us to know that this is where it is at equilibrium. It is actually at equilibrium. But where is this one? Remember, this one is what? Is at initial, right? So this other one is at equilibrium. So the vessel contains 6 mole of SO3. So now remember, this thing is actually sealed, right? This thing is actually sealed, and it contains what? 6 mole of SO3, where? At equilibrium. What are we trying to calculate? Kc. We want to calculate the Kc. So what are we going to use? We're going to use the Rice table, right? Just going to say Rice, Roman race. Okay, so just gonna say rice, right? And then we're just gonna have something like that. So guys, just do this example by yourself and tell me what you find. On the next video, we're just gonna try to analyze everything using the Rice table.